For many years, the energy efficiency and environmental issues have been at the forefront of the electric car business. With its cutting-edge electric motors, which are hailed for their unmatched performance, long lifespan, and low-maintenance design, Tesla has been setting the pace. As you might have assumed, though, that things could not get much better. Tesla has once again pushed the envelope. Tesla's newest motor, which Elon Musk recently showcased, is already wreaking havoc on the industry. It's time to see how this innovative drive unit promises to transform the industry and change our perception of electric vehicles for the better. Before we delve deeper into these topics, please click the like and subscribe buttons to show Wall Street gains your support. Since its inception, Tesla has been creating its drive units. Elon Musk has been the company's product architect from the start, leading the company's initial incorporation under the name Tesla Motors. Tesla has been able to stay at the forefront of the market because to its creative approach to engineering and production. The drive unit in the original Roadster, which was created nearly 20 years ago, was designed and manufactured by Tesla with technology licensed from AC Propulsion, which at the time was only a proof of concept. After Tesla's Model S was introduced in 2012, the drive unit was fully internalized and no longer required a third-party license. Two of the most cutting-edge and effective electric motors available today are the permanent magnet and induction models from Tesla. One of the most popular electric motors on the market today is the induction motor. An electric current is induced in an induction motor through the employment of a number of electromagnets to produce a rotating magnetic field. This generates a force that turns the rotor and releases mechanical energy in rotation. Compared to other motor types, an induction motor's design is simpler and has fewer moving parts, which increases its dependability and low maintenance requirements. Permanent magnet motors, on the other hand, produce motion through the interaction of a magnetic field created by a sequence of magnets with an electric current and a rotor. Because AHAT motors have a fixed magnetic field as opposed to induction motors, they are more efficient and generate less heat when operating. Because of this, they are perfect for use in electric vehicles where dependability and efficiency are essential. For its Plaid lineup of vehicles, which includes the Model S and Model X Plaid, in addition to the Tesla Semi, Tesla has also created a new kind of motor. We're excited to see what Tesla has in store for the future of electric mobility, as the new motor promises to push the envelope even farther. Tesla has always been a business that innovates on features that consumers can see, such power, acceleration, and efficiency or low energy use. Cost, however, is one of the most significant changes that is frequently overlooked. It takes a lot of work to produce high-quality goods at affordable prices, but doing so will make Tesla's technologies available to and used by a larger audience. Despite its moniker, Tesla's Model 3 motor, which powers all of their cars, has already seen cost reductions. They eliminated 20% of the weight, lowered the amount of rare earth metals by 25%, and slashed the size of the plant used to make these motors by an amazing 75% between 2017 and 2022, all of which contributed to a 65% cost reduction. Since Tesla must charge enough to pay all of its expenses, the cost of the facility itself frequently ends up being included in the price of the product. Consequently, cutting the cost of the motor itself also requires improving the factory. Car expert Cindy Monroe and his colleagues observed that Tesla is employing a hairpin electric motor design, which further increases efficiency and lowers cost during the company's most recent investor day. Because this design used rectangular wire rather than the more common round wire, more copper may be contained in the same amount of area, making the motor as a whole more efficient. In the automotive business, Tesla's emphasis on extreme scale and cost cutting without sacrificing high-quality goods is genuinely unique and revolutionary. Hairpin motors are a relatively new technology that's gaining interest in the automotive sector. Electric motors are a crucial part of electric automobiles. Hairpin motors are more efficient than conventional electric motors because they have stator windings in the shape of a hairpin, which lowers wind resistance and enhances heat dissipation. Additionally, the increased copper fill factor made possible by these windings makes for a stronger magnet and ultimately a stronger motor. Tesla has joined a number of well-known automakers who have previously incorporated hairpin designs into their electric cars, including Volkswagen, BMW, and General Motors. Tesla can swiftly iterate through millions of designs to select the best one because to their bespoke software, which is quicker and more accurate than software from rival companies. Because AI can be used to optimize the hairpin winding pattern and lower the motor's resistance while increasing its overall efficiency, this software is also ideally suited for hairpin technology. The accuracy of the copper hairpin bending and welding process is one of the main implementation issues for hairpin technology. In order to solve this problem, Tesla created automated equipment that is currently being used to assemble these motors. This is a significant advancement since improperly welded hairpin ends may result in electrical losses which lower the motor's efficiency. The Tesla charging chip is another example of innovation. Experts claim that Tesla's in-house manufactured high-end semiconductors are the best in the business. The device is now smaller and requires less silicon carbide and costly material because they were able to cut the amount of heat by 2 times and go from 4 to 1 microprocessor. The chip is a notable technological achievement because it retains the same, if not superior, capabilities in spite of these modifications. Tesla has been able to push the limits of what is feasible in the electric vehicle sector thanks to their dedication to software design and vertical integration. Colin Campbell stressed at Tesla's Investor Day that the company can manufacture all of its premium car parts internally, all while maintaining an open line of communication and encouraging involvement from all parties involved. Expanding on its Silicon Valley roots, Tesla even uses software to create hardware. The declaration that Tesla's upcoming motor will require no rare earth metals was one of the event's most impressive announcements. The rare earth metal sector is now a little more uncertain as a result, and the stock prices of firms like MP Materials have dropped. It is a credit to Tesla's engineering prowess that they were able to eliminate these pricey and challenging to find materials without compromising performance. Previously, each drive unit contained 10 grams of two rare materials and 500 grams of an unidentified rare material used by Tesla. Tesla's permanent magnet motor usually contains neodymium, praseodymium, and dysprosium, though the specific metals were not disclosed. These metals are more than $100,000 per ton, or more than $100 per kilogram. Long-term savings of hundreds of millions, if not billions of dollars, will result from Tesla's removal of rare earth metals. Hairpin-shaped stator windings, which lower winding resistance and improve heat dissipation, will also be used in Tesla's next-generation motor. A higher copper fill factor, more copper packed into the same amount of space, is made possible by the hairpin windings, which also makes the magnet and motor more potent. Companies like Volkswagen, BMW, and General Motors have already included this technology into their electric vehicles, even though research on it is still ongoing. Automobiles, and Tesla is doing the same. Tesla has been able to optimize its motors and cut costs in other areas thanks to its dedication to software design. Compared to rival software, Tesla's proprietary software enables them to model and simulate the complete motor, including its revolving electric field, more quickly and precisely. Hairpin technology, which is now at the research stage, is a good fit for this. Moreover, hairpin winding pattern optimization using AI can lower resistance in the motor and raise overall efficiency. Additionally, Tesla has been able to cut the quantity of silicon carbide utilized in their high-level chips by 75% by building them internally. The motor's use of several chip types may be impacted by this reduction in chip size, but Tesla has been able to maintain interchangeability by reusing the inverter casings across all of their vehicles. All things considered, Tesla has been able to push the limits of what is feasible in the electric vehicle business thanks to their dedication to innovation, software design, and vertical integration. Although there are restrictions on what Tesla can do with its present designs, the company will be able to alter its components and save costs with the next-generation powertrain. The next-generation drivetrain as a whole, according to Sandy Monroe and his team, will only set you back $1,000, a substantial savings over the prices of its rivals. Sam Corse of ARK Invest calculated that the cost of the next-generation vehicle's battery pack might be roughly $5,200 with an additional $1,000 for the new power plant. Nevertheless, considering that the upcoming car will be lighter and smaller, the battery size utilized in this computation looks excessively huge. The 45 kilowatt-hour pack mentioned in Hedgehog's response is more accurate. The powertrain will cost $4,100, and the car will cost $16,000. Tesla's ability to construct everything in-house is amazing. This distinguishes them from their rivals who are preoccupied with outsourcing software and parts. Tesla's next-generation motor will be on display increasingly more as they close the gap with their rivals, and this design will probably become standard on the majority of their vehicles. This brings this video to an end. We appreciate you staying through to the finish, and we hope to see you in the future video. Next-generation vehicle's battery pack might be roughly $5,200 with an additional $1,000 for the new power plant. Nevertheless, considering that the upcoming car will be lighter and smaller, the battery size utilized in this computation looks excessively huge. The 45 kilowatt-hour pack mentioned in Hedgehog's response is more accurate. The powertrain will cost $4,100, and the car will cost $16,000. Tesla's ability to construct everything in-house is amazing. This distinguishes them from their rivals who are preoccupied with outsourcing software and parts. Tesla's next-generation motor will be on display increasingly more as they close the gap with their rivals, and this design will probably become standard on the majority of their vehicles. This brings this video to an end. We appreciate you staying through to the finish, and we hope to see you in the future video. Music.